everybody, so we're in P5 and this is the second part, solving equations algebraically. Now, as you look, basically we're going to focus on solving quadratic equations in this section because we did linear last week or the week before. So just thinking about a quadratic equation in x, you have to have an x squared. That's what makes it the quadratic. So it's going to look like something x squared plus something x plus something. And then we're going to equal it to 0 because that's how we're going to find our roots or our zeros. Now, a couple of things. A, B, and C are real numbers. We'll deal with non-reals tomorrow or the next day. And then A can't be 0 because if it were, then this wouldn't be a quadratic because the x squared would go away. So there are 4 methods for solving quadratic equations. You need to write these in. Now, if I talk too fast, it's a video. Just push pause. So, first method, factoring. Oh, one of my favorites. We did some last week. 2, extracting square roots. 3, completing the square. And 4, the quadratic formula. Now, all of these 4 methods work for different problems. So we're just going to look through some problems and think, hey, which of these methods would I use for this one? You pick one and you go with it. So let's see. To solve by factoring, you need to use the zero factor property. And what that says is let A and B be real numbers. If A times B equals 0, then either A has to be 0 or B has to be 0. So how does that all play out? Well, say for example we have x times x plus 1 equals 0. My two zeros, or my two roots, are 0 and negative 1. So we did that a little bit last week. That is lots and lots of review. So here we go. There it is. Okay, so let's look back at example 1a. Oh gosh, that's way before, so that's a different video. And solve it by factoring. Do you get the same solutions as we did before? Well, let's see. I'm going to pull this out. So I know that, let's see. I'm going to pull it apart. It all equals 0. What gives me 2x squared? Well, 2x and 1x. I don't really have to write that 1 there. I've got to multiply to get negative 2, add to get negative 3. If that's the case, let's see. 1 here, 2 here. This has to be plus, this has to be negative because you want those two to be negative 2. But then when they add up, I get negative 3x's, so that's from right here. If that's a problem, let's talk about it later. But the factoring piece, I'm pretty sure we're okay on that. So now I've got 2 different things. They could be 0. We used this when we were looking at the domains and what could x not be. Here it's basically the same. So let's see right here, x would be 2. So today it's what it actually would equal. And right here, this one's going to be negative 1/2. If you're thinking, how did you get that? Well, I just set this thing equal to 0. So 2x plus 1 equals 0. So I could solve through like I'd make you do in 8th grade. Minus 1 divided by 2, negative 1/2. Again, if you need help with that piece, just make sure you check in with me. So these are, we're really looking, these 2 things right here then are the y-intercepts, or the zeros, where it crosses the x-axis. If I had, this is a quadratic, I know it's facing up, so I would cross it negative 1/2 and positive 2. So if I was sketching, it'd be like, which I think we already sketched it. Okay, so there you go, my 2 zeros right there. That's the whole point. So look at, ooh, we got a star. To solve by extracting square roots, you must be able to write the equation in the form of something squared on the left and something on the right. Okay, and remember, when you square root, you get 2 roots. That's that whole plus or minus sign. Okay, so here we go. Solve by extracting square roots. Look at this one. When you look at it right away, you're like, hey, obviously this would be square root. This would be a great way to solve this with square roots. So I'm going to go in. You know that you can take the square root of this thing and the square root of this thing. square root of 9 is 3. Or it could be negative 3. So you're going to have to solve two different pieces to that, okay? So this one I'm going to write in, let's see, the square root of that. 2x minus 1 equals 3. So I'm going to solve it through quick. Again, if I ever go too fast, it's a video. Just pause me. 2x equals 4 divided by 2 divided by 2. So my 0 here is 2. Okay, that's one of them. The custodian guy's slamming doors. And let's see, 2x minus 1 equals negative 3. So I solve that, plus 1, plus 1. Some of these, you are in 11th or 12th grade right now. I mean, seriously, just solve it in your head if you can. I'm fine with that. But be really careful. 3-yard loss, 1-yard gain. That's a negative 2. So your other 0, or your other root, is negative 1. So you've got two of them right there. That would be, if I was quick sketching, it would look like this. I'd have 1 at negative 1, 1 at 2. I see it's all positive, so it's facing up, or it's opening up, I mean. There you go. Kind of missed that. But that's kind of a quick little sketch of where it would cross. This one, this is square roots as well. And you might say, what? Here's why. Look at this. I can pull this apart. Do you see that that's a perfect square right there, 9x squared? Yes. So that would be 3x. 25 is a perfect square as well. So 5, let's see, then plus plus. You might say, are you sure? Yeah, because this gives me the 9x squared, the 25, and then 3x times 5 is 15x, and I'd have two of those, 30x. So that works. So if you see that, just pull it apart and extract the square roots. And then over here I've got 36. So again, I pull them apart, square root, square root. This right here gives me plus or minus 6. Would you agree? Yep. If you don't see it, look over at the clock. You'll see square root of 36 is 6. So I'm going to make two little dealy bobbers. I'm going to make the positive. So x plus 5 equals positive 6. And 3x plus 5 equals negative 6. Now, watch what I'm writing. I think I might have said something different than I wrote a second ago, but we're good. Okay, so I'm going to solve this one because that's the color I'm in. Minus 5, minus 5. And so I go down, drop down my 3x. Oh no, it comes out as a fraction. Of course it does. You're in pre-calc now. It comes out in a fraction almost every time. So divided by 3. So x equals negative 11 thirds. I'm running out of room. This one, I would come back and minus 5, minus 5. So 3x equals 1. The other beauty of a video, if you get it, you just fast forward it and check the answers. Okay, so you've got two roots, one at 1/3 and one at negative 11 over 3. So that, your basic, it would look basically like this. It's opening up. This one would be further over, and then the 1/3 would be right here. But basically it's a U opening up. All right, next slide. Here we go. The technique of example 2 is more general than you might think because every quadratic can be written in that form. When we complete the square. Oh, yes, I love completing the square. So here we go. We've got x squared plus bx equals c. So what is going to happen when we complete the square? We're going to keep the x squared and the bx over here, and we're going to move whatever was here to the other side. Okay? Then we're going to look at this middle part, cut it in half, square it. Now if you add something to this side, you've got to add it to this side as well. So this is review, but we're going to walk through it. Example A. Okay, solve by completing the square. So here's what I'm going to do. I'm going to keep the 4x squared minus 20x over here, and I'm going to end up adding something right there. Okay? Then I'm going to move this 17 to the other side. If it's positive on the left, to get it to the right, I've got to subtract it. So over here I've got negative 17, and then whatever I add, because it's a square, it's going to be an add. I'm going to add right here. I have to add that same thing over here. So I got to figure out what the heck is it? Well, let's see. Let's go through. I look right away and I think to myself, that 4 is gross. I don't want the 4 there. So what I'm going to do is I'm going to divide everything by 4. So I already moved this that 17 over. So now to get rid of this beginning, I'm going to divide by 4. Divide by 4. These I don't have to divide by 4 right now yet because I haven't added them yet. So I'm going to have the same thing to both sides. Right? So let's see. X squared minus 5x plus, I don't know why yet, equals negative 17 over 4 plus whatever I added to the left. Okay, so now I take this negative 5 right here and I cut that in half. So negative 5, I cut that in half, right? Then that's what goes right here. So negative 5 halves, but I've got to square it here. And I've got to square it here. Because whatever I add over here, gotta add over here. So now I'm going to go through, let's see. This is going to end up being x minus 5 halves all squared. It's got to be minus because of that. Okay, now over here I've got to put these things together. So that is, let's see, negative 17/4 plus 25 over 4. All right, so I might be running out of room a little bit, but now I've got x minus 5 halves squared. Okay, that equals over here, this, I'm just going to make a note, that's 8 over 4, which actually is equal to 2. Okay, so I'm going to write over on the side because I'm running out of room. So I've got x minus 5 halves squared equals 2. So I square up both sides, and I'm running out of time on my video. So I'm just going to write this, and then I'm going to pause it, write, come back so you can just see what happens, and you can kind of follow through my work, and then this video shall end. Alright, so what happened was I squared it both sides, so that means I'm going to get either a positive or a negative square root of 2. So I move the 5 halves over to the other side, so x equals 5 halves plus square root of 2, or 5 halves minus the square root of 2. If I calculated that out, I'd get about 1.086, or about 3.914. Isn't that amazing? This isn't always the nicest way, but it works. So come back for another video and we'll keep going.